This is Ushendra from Ushendra's Engineering Tutorials, an introduction to signals and systems. For a beginner, what may be the content, what we will come across. As a beginner, what will we come across in signals and systems? These are the signals, these are the list of signals. Apart from this, we have, but these are the signals which we come across repeatedly, again and again. A lot of problems to be solved based on these signals, right? So, step signal, ramp, impulse, signum function, triangular pulse, etc., etc. So these are the repeated signals which you come across. And how to represent this? The graph, how the graph representation is obtained, and the mathematical representation, right? Coming across, starting with the step function, a very, very, very important signal. We may have few problems when compared to all these. We have a majority of the questions, like a majority of the concept linked up with the step function. It may be a small, it may be only u of, it may be a little concept, but basic one, very important one. So how to represent this step signal? It's a step. The name itself is a step. Whatever we climb steps, right? So that step, it's a step. It's a step signal like this. It's a step. And what we have on the x-axis and what we have on the y-axis. Horizontal axis, we have time here. This. We have time on this axis, and the vertical axis we have the amplitude of this one, right? Remember this one. This on the horizontal it's time period, and vertical the amplitude of the any signal. All these signals the same function, right? And especially this function commences from t equal to 0 and goes on tends to infinity as t tends to infinity. And this being the amplitude, it's, if I say this is one, it's a unit step function. And how do we need to have a representation? This is how u of t is the representation for a step function. Remember this, u of t, it will be it is valid for t equal to 0 to positive values of infinity. This is the truth, right? And what is the mathematical representation of this one? U of t will be equal to 1 for what? Here it's 1 for t greater than or equal to 0, equal to 0 for t less than 0. This is the mathematical representation of a step function here. This is what you have to, the beginner, you may come across. What is the draw a step function? What is the mathematical representation of a step function? Will be the question, right? And if this is u of t, what will be u of minus t? U of minus t. Guys, don't get confused. Nothing to worry. Yep, it's a positive time, so the signal will be that side. It's a negative time, so the signal will be reversed. It's like this one. It may be, it's not maybe, it is. U of t, u of minus t will be this. Just flip, it's 1 again, and u of minus t with time t equal to t tending to minus infinity, t tending to plus infinity. So it's u of minus t, it starts commencing from this one, right? It will be asked, and the limits of integration also changes according to u of t and u of minus t. It's from, for this it's 0 to infinity, and for this one it's 0 to minus infinity. Remember, it's very important. Don't miss these points, basics, right? And other than this one, what if it's asked to represent u minus u of t? What's that? Here the negative, it's a negative is for the amplitude. If this is if something is inside the bracket, that's for the time period, and now this is for the amplitude. It's a positive time with a negative amplitude, so we need to have this one positive t this side to tending to infinity, and negative amplitude, this is the negative amplitude. This is how we represent minus u of t, right? This for minus u of t. So what about minus u of minus t? Right, so this will be the case. Even though amplitude is negative and the time also negative, amplitude is negative and the time also negative. So here we'll be having u of minus t will be this one. This, it will be asked to sketch u of t, u of minus t, etc., etc. Right. And another important point to be remembered while drawing a step function is that you will be coming across to draw if what is a u of t minus 2 like this one. It's u of t, it's u of t minus 2. Now this is an important one, a keen observation please. Now this one, it will be like if it's simply u of t, it starts commencing from t equal to 0. If it's t minus 2, 2 units are removed. It's delayed for 2 units. In the sense, it don't commence from t equal to 0. It doesn't commence from t equal to 0, but it commences from t equal to, let it be t equal to 1 and t equal to 2. Now this step function commences from t equal to 2. These two up to infinity. Yeah, it tends up to infinity. Like we are removing away 2 units. This one, right? We say that it's a delayed step function. It's a delayed step function. So what about this one? What about what if we have u of t plus 2? It goes ahead, right? For u of t, it starts from 0, and this is for u of t plus 2 here. Let it be t equal to 0, t equal to 1, and t equal to 2. Now this one, 2 units are added. It doesn't start from t equal to 0, but it starts commencing from ahead. It's advanced. This one, this will be for this expression. I mean, this is the representation of that one, right? Hope you understand. These are very important. You might not come across this one, right? Remember, this is for whatever happens over here. That's for the amplitude. Whatever happens over here, now we should check in this direction, and whatever happens with the time, we should check in that direction. Remember, this is a basic point, right? So this is what we have. These are the majority for the beginner. You will have to have this information while solving from numericals from signals and systems. This is what with the step function, right? Now coming to the second function, ramp function. How a ramp function? A ramp function is RT, R of t representation, and same like vertical axis with the amplitude and t on the horizontal axis. It will be like this one. It will be like simply like this one, ramp signal, right? So once again, nothing ahead of this r, amplitude is unity, and so what happens is for t equal to 1, even the corresponding amplitude is 1, and t equal to 2, even the corresponding is 2, the amplitude is 2. This is the meaning of this one. So what if we have to draw r of minus t? Guys, it's asked to draw it's asked to draw r of minus t. It's a negative. The time is negative, and simply we have this one. This is the one, like t equal to 0, and just flip the previous version, right? And what if we have minus? We have to draw r of minus t. Negative in the amplitude, so simply negative in the amplitude, right? Negative in the amplitude, positive in the time. Negative in the amplitude, positive in the time. So this will be flipping it upside down. This one will be the minus r of t, right? Same, like what will be minus r of minus t? Remember this one? It's simply in the fourth quadrant, this one. Even though amplitude is negative and time period also is negative. Another useful information. Lot of problems to be done with this one here. So nothing is prior to r here. Prior to r, nothing is prior to r, so that has to be kept in mind. For this, when we mention r of t, it's a linear with time, like this is the arrangement for r of t. And we may be having some 2 times of r of t, 4 times of r of t, minus 4. Then the need comes. We have to keep this in mind and then make use of that one. So how the mathematical representation is for the ramp function? It's denoted as r of t equal to, it's r of t. R of t will be equal to t for t greater than or equal to 0. Once again, it starts commencing from t equal to 0 and tends up to infinity, and equal to 0 for t less than 0. This is the mathematical representation of a ramp function. Even this is important. Moving ahead, another important signal is impulse. This one, how to represent that? It's a del of t, right? It's a del of t, and it's simply a unit impulse function. It looks like this with the amplitude 1. It's amplitude 1 with t on this horizontal axis, t equal to 0. This is the only representation of an impulse function. It has got a lot many applications in signals and systems. An entire chapter depends upon this. On the go, you'll have an entire chapter depending upon the impulse function, making use of the application of an impulse function, right? And the mathematical representation is del of t, a representation of impulse function, is equal to 1 for t equal to 0 in this case, I stress in this case, and equal to 0 otherwise. This is the mathematical representation of an impulse function. Now, what will be this one? What if we have an impulse function like it's t equal to 0 and we have an impulse function units with an amplitude at some place t equal to 2. The same thing, this will be represented with this impulse function again with the unit amplitude. This will be del of t minus 2. Keep this in mind, please. It's in positive time period. What about this one? What if we have a del function like this? It's t equal to 0. We don't have that, but we have the impulse function with a unit amplitude over minus 4 something like this one. Now this will be represented with this one. This will be represented with del of t plus 4. This is the difference. That's why it's been delayed impulse, advanced impulse. Right, this is the representation. The fourth signal being the signum function, signum S G N T M T. It will be like, that's the representation of a signum function. How it looks like: the t on the horizontal axis as usual, extending from t equal to 0 to minus infinity to plus infinity. Okay, and the amplitude on vertical axis. Right, so how the signum function looks like here. This is how I'm changing the color for better understanding, to be more clear. This is the representation of a signum function, and mathematically it's a positive one and it's a negative one. It extends to t equal to 0 to infinity is minus 1, and t equal to 0 to plus infinity it's 1, constant amplitude, right? And mathematically it's 1 for t greater than or equal to 0, equal to minus 1 for t less than 0. This is the mathematical representation of a signum function. This is not over. On the go, while solving some numericals based on signum function, we have to obtain a representation of signum function in terms of a step function. We have a mathematical relation. There is a relation. We have step function. This is signum, and previously we have seen a step function. So there is a need of expressing a signum function in terms of a step function. How that is here? A proof with a proof. Signum of t equal to 2 times u of t minus 1 is the representation, right? 2 times u of t minus 1 is the signum function expressing in terms of step function. Now what is a step function? Step function is step function. We need to substitute the step function and let's check if is that true, right? It's a negative 1 and it's a positive 1. So we need to check. Will that be satisfied for the values of signum function? If is that true or not? Yeah, come back. U of t for t greater than or equal to 0, u of t is 1. So that has to be substituted. Is equal to 2 into 1 minus 1. It's 2 minus 1 equal to 1. It's a positive 1. 2 minus 1, it's a 1. What? Signum function. Signum function. Yeah, it's satisfied. When u of for t greater than 0, u of t is 1 here. u of t is 1 minus 1, and finally we have reached to 1. Yeah, that is for t greater than or equal to 0, signum function is 1. That's 1. It's a proof, right? And on the other hand, for t less than 0, u of t equal to 0. So substituting that over here, that will be 2 into 0 minus 1, and we are left with this will be 0 and minus 1, which is equal to this is for the signum function. Signum function. Now signum function for t less than 0 it's -1. For signum function for t less than 0, it's -1. This is the proof. This is how a signum function is represented in terms of a unit step function. Very important representation. Note it down. Last but not least, a triangular pulse. Even we come across this one. A triangular pulse will be given. How it looks like? It's simply a triangular pulse. Time on this axis, an amplitude over here. This will be the triangular pulse. It's a triangular pulse, right? So we have different mathematical approaches. A lot of problems to be solved regarding time. This one, triangular pulse. We can obtain the mathematical representation of this one while doing a numerical problem. Right? So this is the basic information you need. Now this information is enough to sketch these signals, the basic signals. The previous information is more than enough to sketch these signals. Choosing the first one, this one, it's a u of -t plus 2. For a beginner, it would be better to start with the procedure, right? For this, you have to draw your u of t. U of t is like this one. For this one, step 1 is to sketch this one, u of -t plus 2. We have a negative sign over here. To sketch that, for a beginner to be more clear, you have to draw your u of t. It's u of t like this one. It's u of t, right? Commencing from t equal to 0, and this is u of t. This is u of t. So what will be u of -t? U of -t will be the flipped version of this one. Okay, so how the flipped version looks like here? The same amplitude. The amplitude is 1, right? The amplitude is 1, and u of -t will be this one. U of -t will be the flipped version of this one. Now the final, this one, what we have is the final one. What we want is u of -t plus 2. Now this signal goes ahead. This is at t equal to 0 for supposing. Now t equal to 1, and it may be t equal to 2. Now this signal, the final signal, will be a shifted version of this one. It may be here. This may be like t equal to 0. This may be t equal to 1. This may be t equal to plus 2. Now this one, the final, this one, final signal, this final signal, what it is asked is, now this one, this with an amplitude 1 and shifted ahead. This would be with an amplitude 1. This will be the final sketch of that one, right? And for this one here, the amplitude is -2. Even for this, it would be better to sketch u of t for this one. This is for the first one, and sketching the second one, this is for the second one. It would be better drawing u of t even for this one. U of t is this, right? The sketch will be like this one, commencing from t equal to 0, right? And this one, now commencing from t equal to 0, we have a step function like this one. This is the amplitude. With what amplitude? It's this. Now this is 2, and t plus 2 will be u of what next? We have this next one is u of t plus 2, because that will be the signal commences from let it be t equal to -1. This may be t equal to -2 in that case, and it goes on. And u of t plus 2 will be this one. Plus 2 will be this one. And what if we had an amplitude 2? It's multiplied with 2. This is not the final sketch of this one. The negative amplitude, it should be in this direction. So the my final sketch for -2 u of t plus 2, -2, like my amplitude, it may be, it's a 1, it's a 2, and it's a positive amplitude, and the negative amplitude -1, -2, etc., -3, right? And it's a negative amplitude. Finally, we need to have the negative amplitude commencing from t equal to 1 t equal to -1, t equal to -2. We need to, my final sketch for this one is this one, this like this. It starts commencing from t equal to -2 with an amplitude 2. This is my sketch for this one. Now considering the third one. The third one is, what we have is the third one, like it's a minus 4 r of t. Now this is interesting. A positive time, and this is with a negative slope. It's a ramp signal, right? It's a ramp signal with a positive time with a negative slope. You have to understand if it has got some significance. You have to understand if what is this minus 4. Right? It does matters. Now usual ramp signal like this one. That's a ramp signal, starts commencing from t equal to 0. It starts commencing, right? It's a positive time, t equal to plus infinity, right? Rather than it t equal to 1, t equal to 2, t equal to this point, t equal to 3, etc., etc., right? And this one, for this one, so what it means, like it's a negative slope. If in the absence of this negative, it would have been this one here. I'm redrawing it again for simplicity. It would have been like it may be 1, 2, 3, 4, etc. For a positive, this one, it would have been looked like this one. For increment of 1 unit in time, the slope would have been 4. This is what for a positive. And for increment of another one, that would have gone to 8. The slope would have gone to 8. And we have a negative slope in the reverse direction. It may be like we have minus 1 over here, minus 2 over here, minus 3, and minus 4 over here. And the same t equal to 1. My actual equation, my minus 4 into r of t, this would be my this sketch, this coincidence, this one, this would be my minus 4 into r of t. This one in the black sketch is my sketch for minus t into r of t. Slope is 4. With one increment in time, the slope is 4. With another increment of time, it should be like 8 over here. It should be 8. This is the meaning of this amplitude, right? And the next one, this another one, the fourth one is what we have is 2 times r of t minus 2. Yeah, this is another interesting sketch. It's a positive amplitude, a positive time, but a shifted version. What if for r of t we have this, r of t is this with the unit slope 1 and 1 corresponding 1 and 1, 2 and 2, etc., etc. That would have been for simply r of t. Now we have 2 times of r of t. What it means is here, and it's a positive time, right? What does that mean is this would have been t equal to 0. It's a t equal to 1, 2, 3. Okay, so it starts from, there is a shift over here. Like in my previous lines, I have told you that it's a delayed. 2 units are removed. So in this case, the ramp signal doesn't commence from t equal to 0, but it starts commencing from t equal to 2, not plus 2. That if we would have had t plus 2, would have come this side, added, it's minus 2, so we are removing 2 units, and the ramp signal would start from here, like this. And what is the amplitude in the first unit increment of time? It's amplitude is 2. And as we go on for the next unit of time, it should be like the slope should be here, the slope should be 4. This is my sketch for this one. Let me draw it in black one. So this is my final sketch for this one. The fifth signal to be sketched is for r of minus t plus 3. Now even this is interesting. A negative time with a advanced signal. So what if I need to draw the r of t? R of t would be this. This would be r of t, and r of minus t would be this. R of minus t would be the flipped version of this one. And my final sketch for this one would be from here itself. It may be it is a t equal to 0, t equal to 1, and t equal to 2, and t equal to 3. My final sketch for this equation will be like here. The signal doesn't start from t equal to 0, but it starts from 1, 2, and 3, right? It's advanced version. In this case, going ahead will be giving us plus 3. So it starts commencing from t equal to 3 with a slope unity. In the sense, one increment in time, so one increment in the slope. This will be 1. Another increment of time, it will be 2, like that. Unit increment in slope. This is my final sketch. Let me draw it with another color so that it will be more clear. So this would be my sketch for this signal, this equation. Hope you understand. For a beginner, it's a very, very important information for a beginner who is starting with the signals and systems. Hope you understand. If you find it useful, please share, subscribe, hit the like button. Stay tuned to Ushendra's engineering tutorials for more updates. Thank you so much. Stay home, stay safe.